Howdy, Abby. It's Miss Kosh. I wanted to talk through these notes just in case somebody was absent or whatever. What we're doing here, they're giving us three schools, and they're saying they're given a series of puzzles in 2 hours to solve as many as they can. And then they had school A had 5 kids that each solved 7 puzzles. School B had 5 kids. They solved 5, 6, 7, 8, and 9. And notice I picked these numbers on purpose. And the next school is 3, 5, 7, 9, 11. I was doing this on purpose. They all have a mean and a median of 7. Okay, so that's not as a very helpful piece of information because they're obviously very different. School A, everybody is exactly the same. Sounds kind of boring, but nobody asked me. School B, we've got a range, but it's not a crazy range, I guess. But school C, we've got some really low and some really amazing. And that would be good information for us to know. So what we need more than just the mean and the median. We need ways to measure how spread out the data is. So one of those is that we can find the standard deviation. And so what we do is we take the score. So in the school A, they all had a score of 7. Then we take the deviation. How far is it from the mean? So each one of these, and you'll notice the whole way down, they intentionally, I made the data set easy on purpose. The data set, the mean, so x bar, remember, is the mean. So we take each value here, we subtract it from the mean, and then like you'll notice right here, so on this one, 7 minus 7, it's all 0. There's no variation at all in the data. So on this one, we had some that were -2, -1, 0, 1, and 2. If we add all that up together, we get 0, and that makes us think there's no variation, but there definitely is. Same idea with this one. The -4, -2, 0, 2, and 4 would all add up and give us 0. So we talked about this. Oh shoot, I just forgot. Oh, with chi-squared. That's when we talked about it. We were doing chi-squared test for independence. And so we would square things so that we could still see that there was a difference and we didn't have negatives and positives cancel out. So that to find the standard deviation, we then take the difference here and square it, which does nothing when there is no variation. But now we have 4, 1, 1, and 4. You add all that together and you get 10. This one, the number is bigger because the data was more varied. And so we had 5 elements. Our number of terms in each one was 5. You can see that there. The mean was 7 for all 3 of our data sets. And then, so then the standard deviation is where you take the sum, and that's why this last one is the sum, of the differences between each number from its mean, the distance it is away from the mean, and then we square it to take care of the positive and negatives, and then we divide it by the number of terms. Okay, so on this one, that sum was 10. We had 5 terms, so 10 divided by 5 is 2, and so the standard deviation for this data set is 1.41. The next one we came down to, we had the square root of 8, so 2 root 2, or approximately 2.83, which is telling us that the standard deviation of this data set is 2.83. Well, notice, sure enough, that was the one that was the most spread out, and this is the value that is larger than the other two. So the bigger the standard deviation, the more spread out our data is. Let me do another video for the back. So the back is the IQR. So go find that next video.